Okay, I think we'll go ahead and get started. My name is Greg Groth from Exact Metrology. Today we're going to go over some Design X work. This topic is hybrid modeling. Hybrid modeling is combining NURBS or organic surface data sets with prismatic parametric data sets. So this example is a good example showing we've got this organic shaped blade and we've got this mechanical base that sits at the bottom. So instead of trying to calculate the loft, we can quickly create some as-is surfaces using some of our surfacing functionality, which we went over in a previous webinar. And then we'll kind of hybrid in the base, and we'll create one complete solid using two different methods. So first thing we're going to do to get started is I'm going to create a copy of the data that we have here. So I'm just going to do select all, and I'm going to hit Control C and Control V, and that'll create a copy inside of our tree on the left-hand side here. And the reason I'm doing that is I just want to isolate some of the geometry that we're going to work on instead of using the entire model. So I'm just going to hide one of those data sets. And now we're going to use some functionality to trim up the data set and just get rid of everything that we do not need. So first things, we're going to go to polygons, and we're going to use the split command. The split command is a trimming tool that allows us to use a reference plane, or we can create our own reference, and it'll cut the model wherever that plane intersects. So I'm just going to pick one of these, this particular plane, the top plane, and I can toggle this up and down to a specific location. And I can hit the next button, and it's going to ask me which data, oops, let me back up here. It's going to ask me which data I want to keep. I'll make sure I'm on this mesh. Pick a reference. What the software will do is it'll highlight the area that I want to keep. So right now it's this, I want to keep this upper section, so I'm just going to hit OK. And I'm going to do the same thing again. I'm going to chop off the top. So pick a reference plane. I'm going to move this up. Just go slightly below the top surface. And I want to invert this vector direction of this plane so it keeps everything on this side of the plane. So I just hit the flip and go to the next stage. And it's going to keep this geometry. And so now what we've done is just isolated the data that we want to create NURB surfaces with. And you can see I've got one of the entire model and one of just that localized area. So the next step is we're going to go to our surfacing tool, and we're going to go to the patch network function. Now patch network allows us to create a series of contour lines or splines on this part, and we can fit surfaces along those splines. The previous webinar we did some localized NURBSing. This is a very similar functionality. We're going to let the computer do some of the work. So extract contour curves, and we can play around with sensitivity. This looks at and analyzes the model, how sensitive it is and where it's going to put these contour lines. The default values for this particular example are okay, so we'll go to the next stage. This will take a second or two to calculate. So right now it looks at kind of this trailing edge and leading edge, and it actually assigns some contours, which is exactly what we want. And we can hit OK. So we've got these contour lines in place. The computer was smart enough to figure out that those are on the highest curvature areas. And now we can assign patches to those. So we can do construct patch network. And this example, I'm going to tell it how many patches I want. I want to minimize the amount of surfaces we're putting on there just to make this a nice, simple, lightweight model. So I'm going to use 40 patches. And it'll calculate. You'll see we'll get a nice, clean patch network. And then we'll be able to assign surfaces to those patches. So there's our patch network, nice and clean and ordered. And we can now exit out of the edit patch network. And the next option is we can create surfaces. So what surfaces is going to do is just going to fit surfaces that ride along each of those little patches that we built. And we're just going to hit OK. And what we're left with is a nice simplified surface of that blade. And we can verify its accuracy by turning on the tolerance. And right now I have it set at 0.2 millimeters. We can move that up and down depending on whatever the needs are. We have a really, really accurate surface model of that blade profile. So the next thing I want to do is, now that I have that blade, we're going to solidify it by extending it and kind of capping off the ends. And what that allows us to do is it'll allow it to merge in with this body that we're going to create down here using traditional mesh sketches. So first thing I'm going to do is I'm going to extend everything and just make sure that we're going past the areas that we need so we can trim those off later. So we're going to go to model, and we're going to use the extend surface function. And I'm just going to click on each one of these edges. And I'll do the same for the bottom. And all I'm doing is giving this a little bit extra material to work with when we trim everything. And there we go. So there's our extension. And I just want to verify with my original model that everything goes past where it needs to. So you can see we're sitting below that surface, which is what I want. And now we can kind of cap everything off to solidify it. So the next function we're going to use is called fill face. I'm going to pick one of these open edge boundaries. I'm going to right click and pick select boundary edges. And that's going to pick everything inside that loop, and it's going to cap everything off. So we've got a nice clean cap. We'll do the same on the other end. And this should create our final solid. And you can see the model turn gray. It now shows up in our solid bodies and is no longer a surface. So this is kind of the surfacing portion of that, building this really accurate surface. And now we can go back and we can revert back to our existing mesh sketches and traditional type modeling to build in the mechanical geometry. So first thing I'm going to do is I'm going to assign some regions to this mesh. So we're going to go to region and auto segment and let the software take over. And again, regions are breaking this geometry up into high curvature areas and trying to find some logical geometry using planes and cylinders and cones and 3D features. And this may take a minute based on just the size of the model that you have. The more polygons you have in that scan data, the longer this process will take. So this will take a couple seconds to finish. And then I'll show you how to edit those particular regions. And it should be almost done here. A couple more seconds. There we go. There's our regions. So if I look at my model, it's trying to break this up into, again, logical data sets. Sometimes it cannot calculate them properly. In this instance, I want this should be planar, so I can pick on that particular region and go to my properties tab, and I can reassign it as a plane. So now it should be plane. So now we can start building this actual root of this blade. First thing we want to do is I want to create some references. Currently my part is aligned to a different coordinate system, and what I want is a sketch that goes right through this essentially point of view, and we're going to put a plane kind of right at the middle of the part. So to do that, I'm going to go to my model tab. We're going to use the plane function. First thing I'm going to do is I'm going to create a midplane between this plane face and this planar face. So to do that, I can go to plane, and I can just pick both of those data sets, and the software automatically defaults to, it actually finds the calculation and says, hey, you probably want to do an average of this, which is exactly what I want. And you can see it drops in a preview, and I just hit OK. Next thing is I want to create a curve to assign a direction where this bottom face meets that new plane I just built. So if I go to my vector and I pick those two data sets, it automatically says, hey, I probably want a line where these two planes meet. So you can see it gives me the preview again, and I can hit OK. Now next thing I want to do is I want to create a plane roughly in the middle of this root, and a simple way to do that, a little trick, is if I just create a point on that geometry, I'm just clicking one of those faces. So it just drops a point on that surface, and if I click pre-select both my plane, or my point, and my vector out of my tree, and go into the plane function, again it tries to do the calculation and it creates a point and normal axis plane. So a real nice, easy way to get a reference that's kind of perpendicular to the sketch plane that we're trying to create a sketch plane in the proper direction using a bunch of reference features. So next step is I'm going to create the sketch. So I've got enough features to define where I want that sketch to be built. So we're going to go to our sketch function. And one little trick, anytime you have multiple meshes inside of DesignX, if you notice the mesh sketch is grayed out. To activate the mesh sketch on a particular STL file or mesh, you need to pre-select it. So if I go to my demo, which is the full data set, now mesh sketch is active, and it asks me to pick my reference plane, which is this particular plane, and we're going to create my sketch. So this gives me my profile. We're just going to create a simple sketch along that profile. This is the same kind of things we've gone over in the previous webinars, just building simplified sketches. Oops. And we'll just trim everything out. And we can make our adjustments as necessary. And that should be a nice simple profile minus any fillets. So next thing is I can now I can extrude this profile, and I can extrude it up to these particular planes. And that's kind of the beauty of using this underlying data. So if I go to my model, extrude, and I tell it, hey, I want to stop at this particular region, it makes the adjustment and actually matches that existing angle, and it will do the same in the opposite direction. And if I want, I can merge that in to my existing data set. And now we should have a complete solid of that blade with the hub. Next thing is we can add some fillets. I can use the magic wand to try to calculate the fillet. So this is a best assumption. I can show my underlying mesh to see how that's fitting. And it looks pretty good on both sides. Looks like we're a little high there, and maybe I can knock that corner off for the final modeling. But we'll just accept that value. And there's our fillet. And last thing we're going to do is we're going to use the data to chop off the top of this part. I'll show my mesh and hide my solid. I can use surface primitives to calculate a top plane using that geometry. So if I pick the region I want to apply primitive to, and I specify which type I want to use, in this instance I want this to be a plane, I can hit OK. And what I'm left with is a plane, and I can use that to trim. And then once that's done, I'll show you an alternative. So we're going to use our cut command. The tool would be the plane that we just built. And cut is we're going to cut into this solid. Asks us to pick what we want to keep. And then we're left with a final solid model of a blade. So an alternative to trimming this, if we want to use sketches, if I roll back my tree and I go to my mesh, I can utilize this as a sketch as well. So if I want to go to sketch and I want to sketch on this plane, and I can just create a simple cut feature, and I can use that to cut with. So there's two options there. You can either trim or using surfaces, or you can use it as an extrude feature to actually cut away the data set. And there's our final model. So there's our finished blade example. If anybody has any questions, please let me know. Let me turn off my mesh so you can see the final model. So there's one example. I want to show you another example. We use this technique a lot for tool design. So I'm just going to save this. And I'm just going to bring in a different data set here. Just give me 1 second. Let's do file new. This is another good example of utilizing hybrid data to create tooling. So in this particular example, this is a bottle that we want to build a simple open and shut tool. So first thing I need to do is convert this to a surface. So I'm going to utilize our auto surface function now, and I'll let the software do a bunch of the work. And what it's going to do is just fit approximate surfaces to this 3D data set, and we'll get a surface skin that's really accurate and highly represents the scan data. So we're just going to hit OK and let this run for a second. So there's our auto surface. We'll let it finish applying the actual surfaces. And what we're left with is that surface skin. So now in tool design, instead of going back and creating proper actual surfaces, we can use that really accurate scan data and use it to cut this out of a block. So first thing I want to do is solidify this. It's a little bit easier to work with solids. So first step is we're going to use that same function, that fill face. I'm going to pick all these boundary edges, and we're going to sew everything up. And there's our final solid. So what's nice about solids is it's easier to cut into them and remove things without using the trim function. It acts like a simple extrude or revolve when dealing with solids. So if we want to build, let's say, one side of this tool, real easy. We'll start with a sketch plane. I'll go to my sketch function, and I'm going to skip the mesh sketch. I'm just going to do a basic CAD sketch, and we're going to build the block of our, we'll call it one side of our tool. Maybe I want to add some parameters. We've got some stock aluminum or stock steel in a certain block size, and I want to match those parameters so we don't have to do any extra cutting, no more than we need to. So some basic parameters. There we go. So we're all locked in. And now we can do is a simple extrude. Whatever direction we need to go and whatever height we want. Let's say we've got 75 millimeters thick. And I don't want to use the merge function. I don't want these to combine quite yet because we're actually going to use this to cut this outside of that block. And we hit OK. So there's our basic half of a tool. We're going to use the Boolean command, and we're going to use cut. And I'm going to cut this out of this block, and we're left with a cavity. So now we've got this kind of again, this is that hybrid approach. We've let the software kind of calculate this really somewhat complex organic surface, and then we can use those basic parametrics to define those mechanical shapes to easily edit and make tools of this part. And from here on out, we can start adding we can start adding our bosses to maybe pin or align the two mold halves together. Let's make these the same. Get some value to them. Maybe I want these to be tapered pins. So real quickly, we've taken a 3D data set of that bottle. We've created a simple skin that represents that surface, and we've actually burned it into this mechanical tool shape that we've created, and we've got a real simplified tool. If we're doing resin, some other type of manufacturing process, a real quick way to make the tooling. So those are my two examples. I hope it was informative, and if anybody has any questions, please let me know. Otherwise, I thank everybody for their time, and thank you for watching the web series, and we'll see you later. Thanks.